Most people have a pretty poor association with nuclear energy, but the study of nuclear physics is one of science's best opportunities to achieve cheap, clean energy, and it's enabled some extremely important applications in science, such as MRIs and carbon dating. The first step in eliminating the stigma against nuclear power is understanding it. Nuclear physics is a study of how subatomic particles react with each other and how they're able to form all of the matter in our universe. This is an atom. This is the nucleus, which is made up of protons and neutrons. These things are electrons, but they aren't so important right now, so let's forget about them. Everything around you is made up of molecules, and the molecules are made of atoms, and every atom has a name. Here's a list of them. You can find the name of an atom by counting the number of protons it has, and then finding the number on the table. So this is gold. This is uranium, hydrogen, and this is helium. Those last few are important. There are a few different types of nuclear reactions, and for our purposes the two most important are fusion and fission. Fusion is when two atoms fuse into one, and fission is when one atom splits into two. They're reverse reactions, so they're very different. Einstein first proposed that we could split atoms to get a release of energy in the early 20th century, and that's exactly what happens in a fission reaction. We use a giant atom, such as uranium-235, to split. When atoms are this big, we can fire a lone neutron at them at high speed, and the whole thing becomes unstable and falls apart into smaller atoms. When the uranium atom splits, two atoms remain that have a total mass less than the original mass. Some neutrons are also released, which can set off other uranium-235 atoms and start a chain reaction of fission. The rest of the mass, as Einstein predicted, becomes energy in the form of heat, which then boils water, which turns a turbine, which generates electricity. Now let's go back to the very beginning of our universe. Just after the Big Bang, the simplest of atoms were created, hydrogen, just one proton. Two hydrogen atoms can be pushed together to form one atom, given that they have the necessary pressure or heat. The center of our sun is exactly the sort of location where this reaction can thrive. In fact, the fusion of hydrogen atoms is what's keeping stars burning, and when it runs out, the star dies. In a fusion reaction, some of the matter again becomes energy in the form of heat, which then boils water, which turns a turbine, which generates electricity. All of the nuclear power plants today use fission, which is a pretty good way to generate power, but fusion is better. For one, it releases a lot more energy. It's about 3 to 4 times more efficient than fission, meaning that you get 3 to 4 times more energy output for the energy input. Also, while fission requires uranium, fusion only requires hydrogen, which is literally the most common element in the universe. So the cost of running a fusion reactor would be extremely cheap. But unfortunately, we're not quite there yet. Scientists have had a few breakthroughs recently, but we still need to keep funding nuclear research. After all, nuclear reactions are a beginning, they're our end, and they're literally what we're made of.